always, because we're dealing with very small devices like cables and stuff, we measure in millimeters, centimeters, right? But everything has to be changed at the end of the day into meters, ohms, and amperes. In fact, in a lab, depending on the value of the resistances, because you're not always going to have 4, 3, 6 ohms. You have 1,000 ohms, 10,000 ohms. So we measure currents. In many instances, we measure them in milliamps. So that is important, that you know how to go from one to the other. So here, I'm doing a circuit now. Again, I'm going to put a resistor here in between. Like that. Like that. And it's all going to be connected to a battery here. Like that. Let's give some values that actually help. So 3 ohms and 6 ohms. Yeah. 2 ohms, 4 ohms, 12 ohms. All right, so 28 volts. Let's see if I got this right. So the battery is 28 volts, and you have 2 loops now, and 1 resistor in the middle. So let's recall our theory. What we know from the theory is that the current, even though we know it should be going this way, right? Electrons flowing. The convention we are going to use is that the current goes like this. Right, that's your current of the circuit, I total. And then it's gonna encounter that junction, so it's gonna be divided in here and here, right? And then you will have the current meeting at this junction here, and then again, this total current will be here, right? It's split. It goes back to the same, but then it splits again. And then we have that they join back here, and then goes all the way there. In real life, in real life, it's not very common to see circuits as simple as it is. Yeah, believe it or not, that's a very simple circuit. All right. In real life, you have more loops and other devices, right? So we will get close to more realistic circuits when we go into Kirchhoff laws. One difference that we will be doing in Kirchhoff laws next week, or maybe even tomorrow actually, is the fact that we normally have more than 1 battery, more than 1 power supply, all right? So in a real scenario, if you have two or more batteries and 2 or more junctions, 2 or more loops, you have to use other rules to understand how the current behaves. So it's not as easy as says there is a junction and it splits. It's not that easy, right? There are other things going on, and there are other rules that we will be applying. But for now, we can use this, right? Okay, so the first step will be to find the equivalent resistance. So first of all, we know that this is in parallel, and this is also in parallel, and then these all 3 are in series, right? So again here, 1 over R, 1 over 3, 1 over 6. If you do your math, this will be 2 ohms. Here, 1 over R, 1 over 12, 1 over 4, So R becomes 3 ohms. So I can put here 3 ohms, 2 ohms, so 2 plus 2, 4 plus 3. The equivalent resistance is 7 ohms. So we put here 7 ohms. Part B, find the current on the circuit, the total current. Using Ohm's law, V over R equivalent. 28 divided by 7, 4 amperes. So I have half the problem, or even more than half of the problem solved, right? I found REQ, I use it to find the current on the circuit, 4 amperes. Perfect. Now, let's split the currents. We have to find the current on 4, the current on 12, the current on 2, the current on 3, and the current on 6. All right, can somebody tell me what's the current on 2 ohms? So what's the current here? Just think about it. Imagine you're in the exam right now. What's the current on 2 ohms there?
Is it V divided by R? So is it 28
No.
divided by 2? But I think
No.
that's...
No, it's 4 amperes. Your current, if you were doing what you said, you will have 15 amperes. You can never have more current than the total current. That's the maximum current you can have in the circuit. The current here is 4 amperes. Because if you look at what I did on the graph, right? The current 4 amperes gets split, it's divided, and then it goes back to what it was originally. How much was originally? 4 amperes. So for this resistor here, it has all the current. This is the total current. All right, so very important. You can never have more than the total current on any electrical device inside the circuit. That's why it's called the total current, I total, or I of the circuit. All right, that's the maximum value. So that means that the current on 4, 12, 6, and 3, they all have to be less than 4. All right, so that's already an idea of what the answer should be. And that will help you to know if you're doing something right or wrong, okay? The same happens with capacitors. When we do review capacitors today, the charge of the circuit, the total charge, you can never have more charge than that in any capacitor, okay?
Sorry, Professor, can you tell me again how you got 4 amps for the total current on B?
Divide 28
Oh, okay.
equivalent resistance.
Okay, I was reading that as 23. I'm sorry.
All right, so 28 divided by 7, that will give you 4 amperes. All right, so how do you find the current on 12 and 4? Like we did with capacitors, I'm gonna find the voltage here. Why? Because the voltage on 12 is equal to the voltage on 4. Okay? So these two are in parallel. Let's put here parallel. Right? So they share. So is V4 equals to V12 equals to what? Equals to the current 4 times 3. It's 12 volts. So how much is 12 volts divided by 12? 1 ampere. How much is 12 volts divided by 4? 3 amperes. How much is 3 plus 1? 4 amperes. You see what I did there? I split the current using the potential drop. Right? So I found the voltage on the loop. The same here, on this loop. On this loop here, I'm going to find the voltage on that loop. 3 and 6, they also share the same voltage, which is 4 times 2, 8 volts. So what's the current on 3? 8 divided by 3. What's the current on 6? 8 divided by 6? 4 over 3. All right. Those are fractions. 4 over 3. 4 over 3 plus 8 over 3 is 12 over 3. How much is 12 over 3? 4 amperes. So that's how you do it. Any questions? Come on. So I want to do another circuit. This actually could be a question in the test. Not gonna lie. So I feel like resistors is actually easier than capacitors. Numbers like that, of course. All right. I normally give very nice numbers, but the level will be like that, right? REQ, the current on the circuit, and then find the current. I'm not gonna even ask, find the voltages, because that's part of the problem already. I will just ask to split the currents. In fact, for tomorrow's quiz, for capacitors, I probably will just ask to split the charge as well. All right. So, does anybody have any questions about this? Nobody? Okay. It's all recorded. Yes?
Sorry. How did you get V3 equals V6 equals 8 volts?
You multiply the total current by the resistor on the loop, which is 2. So 4 times 2, 8 volts. You know that these two combined give you 2 ohms. So you just need to multiply the total current by the 2 ohms. Make sense?
Yeah, I got it. Thanks.
It will make more sense, and that's the thing. That's why this is not going to be in tomorrow's quiz. It will make more sense when you do the lab on this, which is tomorrow. So tomorrow, is in series and parallel, and you will be doing all this. All right, and practice is the best way to master all this. So as more you practice this, as more clear things will be. Right? Let's do another circuit now. All right. Please make sure that you are also watching the videos I uploaded. All right. Because they complement all this with the videos you have. Oh, by the way, is everybody having access to the lecture videos, the lecture recordings? Or is anybody having any issues to access them? Oh, there is a question.
I haven't had any issues, Professor.
Okay, yes. It should be all embedded already in Canvas. If you need a password, all the passwords are in announcements, right? But they are already embedded. If anything was to happen with those videos, I have backups, okay? So don't worry, we won't lose any recordings. Okay, let's do another circuit. Let's do it a bit more complicated now. Or at least another type of circuit. So now we are gonna have battery here, positive, negative, a resistor here, and then you will have and then you have a split here, a junction, but you have a resistor here. There's another junction inside. Like this. And then another resistor here. And they close here. And they go all to the battery here. All right, so that one, they have here 2 ohms, 8 volts, positive, negative there, 5 ohms, 10 ohms, so we will probably get fractions in there, that's okay. 3 ohms, 4 ohms. So, okay, so we're gonna find everything as we have. First, the equivalent resistance, and then the total current on the circuit. Let's understand again what's happening on the problem. We have the current going like this. Then it gets split. Like that, and like that. Is more in here, right? So it gets split and then it's split again. It goes back. That's another junction here, junction. 1 here, so there's 4. And now they go back here, all the way back in there. So this is the current total, and then we want all the equivalent resistance. All right? Okay, so let's start. The equivalent resistance is the easy part, right? Just do series and parallel. So we go from the inside to the outside. So the first thing will be to deal with this loop. All right, so for this loop here, they are in parallel, 5 and 10. 1 over R equals to 1 over 5 plus 1 over 10. So how much is the R? 10 over 3, right? 10 over 3 ohms. So I have 10 over 3 ohms in series with 4 ohms, and then all of them in parallel with this guy here, 3 ohms. All right. So all this was converted to this. Now, 10 over 3 plus 4, these are in series. If you add them together, you will get 22 over 3 ohms. If you do the series combination. And now we're gonna do parallel between this and this. Right? So 1 over R equals to 3 over 22 plus 1 over 3. Now, if you want to do this quickly, the rule will be, actually no, this is fraction, right? So 66, then I have 9 plus 22, that's 1 over R. then R will be 66/31. All right. At this point, you can estimate that. So let's do fractions. Let's do decimals now. $66. Okay. So this resistance of all this is 2.13 ohms. So let's use decimals now. But then I have 2 outside. So all this is 2.13 ohms. And this 2 is outside. So the equivalent resistance will be 2 plus 2.13, 4.13 ohms. So that's the value for the equivalent resistance then. All right. So again, I had this, the only thing that was harder here were the numbers, right? You had a fraction for the equivalent here, which is there. They had them in series. When you join them together, you get that. And then when you do the parallel between 3 and 22/3, you get this. And then with 2, you get that. And to find the current on the circuit, you just divide 8, divide by 4.13, 1.94. So the current on the circuit will be 1.94 amperes. Because this circuit is longer, or is more difficult, the only thing that you could be asked, right, once you finish this, will be find the current here and find the current on 3 and 4 amperes. So let's ask those questions. All right. Let's do that in there. So you can write it down. So as an extra, now we're going to split some of the currents. Let's find the current on 2 ohms, and then I want you to find the current on 3 ohms. Oh, here, and there. So directly, what's the value of the current on 2 ohms?
1.94.
Yes, very good, right? It's 1.94. Just if you look at the graph, at the lines I did, the total current is the one that is passing by 2 ohms. It doesn't split. It only splits when it enters the loop. So very good. The current on 2 is 1.94 amperes. Almost done. Now, let's find the current on 3. To find the current on 3, because you're inside this loop, basically here, right? You want to find the voltage here. There are 2 ways you can do that. Let's suppose you are, or let's suppose you did it like I did here. You know that the resistance of this loop is 2.13. So then, right here, the voltage on the loop is the voltage on 2.13. And that voltage is 1.94 times 2.13. So that will be, so this will be 1.94 times 2.13. That will give me, I'm gonna give you the other way as well, okay? So 2.13 times 1.94, 4.13 volts. What's the other way to know this guy? So how do you know that that's 4.13? Easy. The current here, as you said, was 1.94 amperes. By conservation of energy and charge, the total voltage of these two, the loop and this resistor, has to be 8 volts. How much is 2 times 1.94? 2 times 1.94 is 3.88. If you subtract 8 from there, you get 4.13. So you can also use 8 minus 1.94 times 2. That gives you also 4.13. So why do I need that? Because the current on free will be 4.13 divided by 3. Why? Because the voltage here is the same as the voltage here, right? So that current will be 1.38 amperes. Less than this, right? And easy, the current here will be 1.94 minus 1.38.56. I didn't ask that. So that was a bit more complicated, but the idea is the same in terms of splitting the currents, right? If you have a resistor outside of any loop, it's easy to know what's the current and also its potential drop. And you can use that to find and split the currents here.